Hello, in this video, I will explain to you on how to solve this problem. A 13-feet ladder is leaning against a house when its base starts to slide away. See the figure? By the time the base is 12 feet from the house, the base is moving at the rate of 5 feet per second. Okay, we know that this one is x here, the base, and the height here is y. Okay, and then let's see the question A first. How fast is the top of the ladder sliding down the wall then? So it needs to find out dy dt here. Okay, let's analyze the relationship between the wall, the floor, the wall, and the ladder. Okay, we know that this is a right angle, so we know that it can be calculated using Pythagorean theorem, right? So we'll have Pythagorean theorem here. Okay, we will have this x squared plus y squared is equal to the length of this ladder, right? So we'll have 13 squared. Okay, and then what can we do from here? We can derive both sides here with respect to t. So here we can use implicit differentiation. So we will have 2x, but this is with respect to x. We need to multiply it by dx dt. And then we can also differentiate this. So we will have 2y dy dt. And that will equal to 0, right? We can divide both sides by 2, so these 2 will cancel out. Okay, and we need to find out dy dt. So let's isolate that. We will have y dy dt here is equal to minus x dx dt. And we can isolate that, so we'll have dy dt here is equal to minus x divided by y, then multiplied by dx dt. Okay, now what we need to do is plug in the numerical values. Okay, we know that x is 12. Okay, we'll have x is equal to 12. And we can also given that dx dt is 5 feet per second. Dx dt here is 5. However, we don't know the value of y yet, but if x is 12, we can calculate that using this one, right? So we will have y here is equal to the square root of 13 squared and then minus x squared. But x is 12, so I will have 12 squared. And so we will have y is equal to the square root of 169 minus 144. Or that will be square root of 25. And y is 5. Good. And then we can plug in the values here. So we need to find out dy dt when x is equal to 12. Okay, so we plug in the values of this x. So we will have minus 12 and then divided by y, but y is 5. And then we know that dx dt is 5. So we'll have 5. And that 5 here will cancel each other, right? So 5 and 5 will cancel. So we will have minus 12. And what is the unit? Y here is in feet, right? So we'll have feet. And the time here is in seconds. So I'll have minus 12 feet per second. And that is the answer for question A. We'll have minus 12 feet per second. Okay, let's write it that here. Minus 12 feet per second. Okay, and now let's clean this up and move on to question B. Okay, for question B, we need to find out the area of the rectangle. Area. What is the area of a rectangle? Let's denote that as A here, and the area is 1/2 the base, so we will have x, and then multiplied by the height, we will have it as y. Okay, and then we need to find out the rate of change, which is dA dt. Okay, and that will be 1/2 is a constant, so that is not a problem. But we have some problem here. This is multiplication between two functions, right? Because this x is a function of time and y is also a function of time. So we need to find out the derivative of the multiplication of two functions. But we know that the derivative of two functions here, u v prime, is equal to u v prime plus u prime v, right? Okay, and we can rewrite that here. So let's use this x here as our u and this y here as our v. Okay, we have our u, which is x, and then v prime. V prime is a dy dt. And then we will have plus here. Okay, we will have, what is it? U prime v. Our v is y, but u prime is dx dt. Good. Now we have all the values, right? Okay, now let's use the numerical values here when x is equal to 12 meter. Right? Okay, let's see here. Yeah, x is 12 meter. So we will have dA dt when x is equal to 12. Okay, let's plug that in. I will have 1/2. What is x? As x is 12. Okay, but then what is dy dt? We already calculate that in problem A, right? What is dy dt? Minus 12 feet per second. So we will have minus 12 here. Minus 12 feet per second. Okay, and then plus y. What is y here? Y, we already calculate that. That is 5. Okay, we'll have 5. And then dx dt, we also given that that is 5. Okay, and all that we need to do is to calculate this, right? Okay, maybe let's change the bracket here into square brackets so I don't get confused. So we will have 1/2, and then we will have minus 144 plus 25. Okay, I think I just use calculator to avoid any mistakes here. So we will have 1/2 multiplied by minus 144 plus 25. Okay, I will have minus 49.5. And what is the new unit? The area is feet square and the time is in second. So this is the answer for question B. I will have minus 59.5 feet square per second. Okay, and let's clean this up and answer question C. Okay, the question C asking us about at what rate is the angle theta between the ladder and the ground changing. Okay, so we need to use trigonometry here. Okay, what can we do from here? I think I will use sine of theta, right? So let's use sine of theta here. What is sine of theta? Sine of theta is the opposite divided by the hypotenuse. So I will have y over 13. Or we can have y is equal to 13 sine of theta. And we can get the rate of change of y here, dy dt here. is equal to 13, and the derivative of sine is cosine of theta. But by the chain rule, we need to multiply this by d theta over dt. But then what is cosine of theta? Cosine of theta is the adjacent divided by the, what is it? Hypotenuse. Okay, so we'll have dy dt is equal to 13, and then multiplied by x over 13. Okay, and we will have this one cancelled, multiply this by d theta dt. And the question is asking us about d theta dt. So we'll have d theta dt here is equal to 1 over x multiplied by dy dt. Okay, now we can just plug that in, right? So we will have when x is equal to 12. Okay, what is d theta over dt when x is equal to 12? Okay, now we will have 1 over x, and then x is 12, right? So we will have 12 there, 1 over 12. And then what is dy dt? Dy dt, we already calculate that here, right? So we'll have minus 12. Okay, and I will have minus 12 here. What a nice number. So let's cancel this out. So we will have minus 1. And the unit of theta here is in radian. And the unit of time here is in second. So we'll have minus 1 radian per second. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye-bye.